Hello students, welcome you all on YourPedia Education. So my dear students, if you are preparing for GATE Data Science and AI, so in this series, as you know, YourPedia already launched a series where we just discuss top important questions of each and every subjects. So now my dear students, in this video we are going to discuss the DBMS 10 important question. So my dear students, if I talk about the DBMS, what you have to prepare? First of all, you have to know how to find out the super key, how to find out the candidate key, how to find out the highest normal form. Moving towards the indexing part, you have to know what is the definition of indexing, like primary index, secondary index, cluster index. Then you have to know the block factor, number of keys in non-leaf node or number of block pointers, or total number of blocks required. Then moving ahead, you have to know, if I talk about the transaction topic, then in transaction you have to know what do you mean by schedule and recoverability, serializability, conflict serializability, transaction concurrency protocol, like mainly the 2PL and strict 2PL. Fine. Next, moving ahead with the timestamp ordering protocol, that is basic anthems, you have to know the properties or the characteristics of these two protocols. Then the SQL part or the relational algebra part is the most important part. Yes, you face at least 2 questions from the query language that consist with 3 or 4 marks problem. Fine. Then in the warehouse, again we have some small part of warehouse, so you have to know different techniques of warehouse also. From the warehouse you may expect 2 marks problem. So my dear students, in this video mainly I just talk about the top 10 or the 10 important question of database management system. And my dear students, if you want the solutions PDF, questions with the solution PDF, then you can access all those solutions PDF from the YourPedia panel. But what you have to do is, you have to fill the Google form with your query, whatever the key questions they ask. They are simple, like what's name, your degree, or all this stuff. So after filling the Google form, you are able to access this PDF questions with answer PDF from YourPedia panel. Moving ahead, my dear students, the first problem is total number of super key possible for a relational schema are. I am trying to take the question from each and every topic in this video and in the next video also. So the first problem is, we have to find out the total number of super key. We know that how to find out the total number of super key. So my dear students, if I talk about the total number of super key, we know that here the given point is, we have a relational schema R with A, B, C, D and E. Fine, my dear students, we have 5 attributes in relational schema R, and the key is, one key is A and one key is BC. So now my dear students, can you just tell me total number of super key possible with key A? We know that 2 key power total number of attribute 5 minus number of attribute in this key 1 plus total number of key or super key possible with the candidate key BC is 2 key power 5 minus 2, and then we have to subtract the super key which contains A, B and C, all 3. Fine. So 2 key power 5 minus 3. So here 2 key power 4 plus 2 key power 3 minus 2 key power 2, which is going to be 2 key power 4 is 16 plus 2 key power 3 is 8 minus 4. So answer is 20. So 20 is the right answer. Keep in mind, my dear students. Next, my dear students, the next point is, what is the candidate key for relation R? Now just tell me what should be the candidate key. See, my dear students, we have the given point, we have a relational schema R, given is A, B, C and D. Fine. And the FDs are A determine B, B determine D and D determine C, and C also determine functionally or uniquely determine D. Now tell me what should be the candidate key. talking about if I just find out the A closure, I'll get A determine B. Now can someone determine is out of A and B is they are determining C or D? No. So A is not the candidate key. So the point is, can you just find out AD closure? See my dear student, AD closure. With the help of AD, we can find out AD, and A determine B and D also determine C. So A, B, C, D, all the attribute of relation R is uniquely determined by AD. Fine. Now tell me, is A is present on the right hand side of any FD? No. Is D is present? Yes. So we can replace D by C also. So AC closure also give me A determine B, C is C, C determine D. So these two are the candidate key of relation R. Fine. Moving ahead, my dear students, the next point is consider the following relational schema, and given the decomposition, we have to find out the decomposition is lossless, dependency preserved, not lossless, not dependency preserved, and others case. So tell me, my dear students, what should be the answer? Please solve it fast and tell me the right answer. See, my dear students, if I talk about this is my FD number 1 and this is my FD number 2, and if I talk about decomposition, the first decomposition R1 is A, B and C. Talking about the second decomposition R2 is A and D. Now tell me, my dear student, what should be the FDs of R1? Moving ahead, the FDs of R1 is AB determine C. Now D determine A. D determine A. Anything else we can get here? No. So here D determine A is the FD. Fine, my dear students. Now is AB determine D not be there? Then fine. So these two are the FDs of individual subrelations. Fine, my dear students. One FD set is this one, for this one. Now tell me, is the sub decomposition is lossless or not? What we have to check? The union of attribute of R1 and R2, that is A, B, C, and AD is A, B, C, D, that is equivalent to R. Fine. Now is there any common attribute? Yes, A is the common attribute in subrelation or in decomposition R1 and R2. Now tell me, is A is key of any of the subrelation? No. Here key is AB, here key is D, that's why A is not the that is A is not the key of any of the subrelation, that's why it is lossless. Lossless decomposition, lossy decomposition, not lossless. It is not lossless decomposition. Now moving ahead, is it dependency preserved? Now see, my dears, we know that we can write AB determine CD as AB determine C and AB determine D. With the decomposition rule, right hand side we can split. Now AB determine C present, AB determine D determine A, we have one more, that is D determine A. D determine A is present, but is AB determine D is present? No. How you can check? Just find out the closure of AB. AB closure with the help of these two FDs. AB closure is AB. AB determine C. But how we can determine D? So AB determine D is not possible. That means it is not dependency preserved. The right answer is not lossless, not dependency preserved. Next problem, my dear students. Again we need to find out the highest normal form. To check the given the highest normal form, first of all you need to find out the keys or the candidate key of that relation. Now my dear students, can you just tell me, is AB is a candidate key or not? Find out the AB closure. AB gives you AB, AB determine C, C determine D, D determine E. Now as B is determined by D, so AB is a key. Fine. Now tell me, yes, C, find out the C closure. C is C, C determine D, D determine E, E determine A, D also determine B. C is, now check D closure. D is D, D determine E, E determine A, D determine B, AB determine C. Now A is derived by E. So we can replace A as EB. EB is a key. Yes. EB. E determine A. AB determine C. C determine D. Now B. B is also determined by, so AD. AD is a key. Now tell me, AD is AD. D determine B. Now see my dear students. B, now AB determines C, C and AB determine B, D and E. But now tell me, is AB and AD are the key? AD is not a key because the subset of AD is D, which is also a key. So it is not the minimal one. Keep in mind, it is not the minimal one. So keep in mind that point. So AD is not a key because D is a key. So by default AD should be a key, but it is not the candidate key, but it is a E. Here we have E. Keep in mind, here we have E. Fine. So D is a key, but AD is not a candidate key. Why? Because candidate key should be minimal. Now tell me, my dear students, to check that a given relation is in 2NF or not, first of all, to check the relation has partial dependency or not. If partial dependency, that is not in 2NF. To check partial dependency, left hand side should be proper subset of candidate key and right hand side should be non-prime attribute. And if this condition follows by any of the one FD, then you can say it is not in 2NF. So check, is AB is proper subset of key? No. C is proper subset of key? No. D is proper subset of key? No. E is proper subset of key? Yes. But E determine A. A is not a non-prime attribute, it is a prime attribute. Now D is proper subset of key? No. It means there is no partial dependency, relation is in 2NF. Now to check the given relation is 3NF or not, what you have to do is, you simply check that if there is transitive dependency, then you can say that the relation is not in 3NF. Or what you have to do is, just check left hand side is key or, not the end, I am using or here. If left hand side is key or right hand side is prime attribute, if this condition is followed by the FDs, then that FD is in 3NF. Keep in mind. Now, is left hand side is a key? Yes sir. So either left hand side is a key or right hand side is a prime attribute, then that is in 3NF. If left hand side is a key? Yes. Is left hand side is a key? Yes. Left hand side is a key? No, but right hand side is a prime attribute. Is left hand side is a key? Yes, that's why it is in 3NF. Fine. Now check for BCNF. In BCNF, left hand side should be key. AB is key, C is key, D is key, but E is not a key, EB is a key. That's why not in BCNF. So highest normal form of this relation is 3NF. The next is, suppose in a B plus tree, the given search key size is given, that is search key is 12 byte, then block size is given 1024 byte and block pointer is given 6 byte. Fine. Now the maximum number of key that can accommodate in each no leaf node, we know that in B plus tree we have n block pointer, then n minus 1 keys are there, fine, which should be less than equal to block size, because there is no record pointer in the internal node, we have record pointer at only on the leaf nodes. Fine. Now n block pointer size is 6 byte, 6n plus n minus 1 k size, search key size is 12 byte, 12n minus 1, which must be less than equal to 1024. Now you have to find out the n value. Fine, my dear students. Now keep in mind, my dear students, suppose that the answer is like this. If n is 15, then your answer should be n minus 1, that is 14. So key you can accommodate is 14. This is the first case. But the second case is, suppose that you will get n is equal to 15 point something, any value, 1, 2, 6, 5, 9, 9, anything. Suppose that 6, 5. Then again key should be 14. Why? Because you cannot accommodate 15.65 block pointer in a block. Either you can accommodate 15 or 16. If you take the seal value, then it is overflow, your block will be overflow. That's why you have to take the sealed value of block pointer or n. So n minus 1 is 14. Keep in mind that point. Now my dear students, that is very important problem. See, if the nested query output is empty, okay, then x is any value, suppose that it is x1 operator, you can take any operator, maybe greater than, less than, not equal to, less than, equal to, greater than, equal to, then any with empty set, okay, and here again x1 greater than all of empty set. Fine, my dear students, it says that x operator any with empty set returns true, which is a false statement. It always returns false. Keep in mind. And x operator all with empty set always return true, that is false, it always returns true. It means both the statement all false, the number of statements which are correct is 0. Now see, listen carefully my dear students. What the first point is, 5 greater than any of the empty set. To prove this condition, there must be any of the value, there must some value such that you can prove, yay, 5 is greater than at least of any, means at least of this value. You have to prove, you can prove this statement only if we have some values, but we don't have the values in the nested loop. That's why it always returns you false, because you are unable to prove this statement. But in the case of all, 5 greater than all of empty set, instead of proving, if we go for disprove, 5 is greater than all of this value, are you able to disprove this statement? No, because to disprove this statement, you must have at least one value in your set which dissatisfy this. That's why it returns you true, because in the case of all, disprove is the easy one. That's why, but you must have some values to disprove this one. That's why you are unable to disprove, that's why it is always true. But in the first case, you are unable to prove something. Fine, that's the main reason. So this point you have to always keep in mind, make a notes that x1, x greater than, or x operator any with empty set always return false. Well, as this point, in the case of all, it returns always true. For that you can also refer Navathe. Fine, my dear students. Now this is an important point. So first of all, I want to give you some short notes point here. See my dear students, to find irrecoverability, recoverability, cascadeless or strict recoverability, we have some standard 4 case. You have to keep in mind these 4 case in your mind. See, first one is T1 and T2. Suppose that T1 is write something, then T2 is read that data item, and but T2 is commit first, then T1 commit or roll back. It means it is a irrecoverable schedule. If this case you can see anywhere in your problem, irrecoverability. Next, T1, again you have to make these note points in your notebook. Suppose that is write, that is data item, the data item must be same. Now if I want to make it recoverable, we have to delay this commit operations. Fine. So first commit this one, then commit this one, so it is recoverable case. Then we can say that we are able to recover the schedule. If some failure is there, yes, we can recover or undo T2 also. Next, T1, T2. T1 is read the data item, then after commit only T2 is able to read, but it can do perform of write. Fine, but read is only allowed after commit of T1. That case is called cascadeless. And the next scenario is T1, T2, T1 is write something, after commit only either you can read or you can write. Here you never read, you never write, that's why it is strict recoverable. Fine, these are the 4 scenarios you have to keep in mind. So please make a note down. Now moving ahead, see my dear students, in this case if we move on the problem statement, see here T1 is writing, T2 is reading, but T2 is committing first, that's why it is irrecoverable. To make it recoverable, we have to commit this delay after this commit, as simple. Now my dear students, every 3NF is in BCNF but not vice versa. This is a true statement, because to become a relation into BCNF, first of all relation should be in 3NF. That's why first is right. BCNF is lossless and dependency preserve. It is wrong statement, my dear students. Sometimes in BCNF dependency preserve is not possible. That's why 3NF is the most adequate form or the normal form. Why? Because 3NF always be lossless and dependency preserve, but the statement 3 says that 3NF not preserve dependency but always lossless. This statement is true for the BCNF but not for the 3NF. That's why the correct statement is only first one. Next, which of the following query is correct to find students whom no department is assigned? No department, it means we have to check where in the column of DID which student have the null values, and to compare with the null values we are always using is null instead of equal to, because equal to we cannot perform any comparison, any arithmetic operation with the null, because null don't have the specific meaning. It may be unknown, it may be unexisted. Fine. That's why the correct answer is 1. If we want to perform any operations with the null, we have to do null or is null. Null or not null. Fine. Next, consider the following statement. 2PL is free from irrecoverability. No. Keep in mind, my dear students, 2PL have mainly 3 problems. It not free from irrecoverability, it not free from deadlock, it not free from starvation. But it always ensure serializability, that is conflict serializability. That's why 2PL is not free from irrecoverability. Sorry, 2PL is free from irrecoverability. That is false statement. So if we go with the first statement, is false. Next, 2PL is not free from deadlock. This statement is true. 2PL ensures serializability. True. 2PL not free from starvation. True. So last 3 statements are true. First one is wrong. The number of statements which are correct is set 2, 3 and 4. So my dear students, these are the 10 important problems. I am trying to cover each and every topic, like we go with that indexing also, we cover SQL part also, we cover candidate key, super key part, normalization part, transaction part. Fine, my dear students, these are some of the important topics or important questions I just consider, and in the next video also we are going to cover the data warehouse questions. So my dear students, if you want to download the questions with the answer PDF, then what you have to do is you just need to fill the Google form, which is already in the description. So my dear students, you can just fill the Google form and you can access all the questions with the answers for the AI, ML, DBMS, Python, stats, calculus, matrices or linear algebra, data warehouse, DBMS, data structure algorithm. All the content of this series, questions with answer, you can download in the PDF form. But what you have to do is you have to just fill the Google form, which is attached in the link below. Fine, my dear students. Still, if you have any query, please write down in the comment section box, or you just call to the executive of YourPedia. So we will contact you. Thank you.